In this video, part 2 of my notes from section 3.4, we're going to be looking at repeating linear factors. So what it tells us right here in the rule is, once again, we're putting constants in the numerator. But you'll notice that here's my linear factor, ax plus b. But here I have ax plus b to the second power, dot, 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 all the way up to ax plus b to the nth power. And so that just adds another layer of complexity to this, which means that if we have something like 2x plus 1 to the third power, I need to put a 2x plus 1 to the first power, 2x plus 1 to the second power, all the way up to the 2x plus 1 to the third power. So let's just do the first example. So I take a look at this, and I have a linear factor, degree 1 in the numerator, and I have a degree of 3 in the denominator, but it's already factored. So if you took the 2x minus 1 squared and squared it, you're going to end up with a squared factor times the x minus 1 factor will give you a cubic factor. So you have a total of a third degree of polynomial. So we do not need to do long division here. So I am going to, but I notice that all of these factors are linear. Now, do not get confused by the fact that this factor is squared. This 2x minus 1 is a linear factor. I just happen to have 2 of them. So it is a repeating, because I have 2 of them, linear factor, as opposed to something like 3x squared plus 1. Okay, this is a quadratic factor that cannot be broken down into a linear factor. It is what we call an irreducible, unfactorable quadratic, because it's second degree factor. So that's in the next section. All right, so right now we have repeating linear factors. So we start off the same way. We factor the denominator, which it's already factored. Then we have the repeating linear factor. So I put the 2x minus 1 to the first power, then 2x minus 1 to the second power, because that is the highest power of 2x minus 1. We have to have a separate fraction for each power of 2x minus 1 up to the second power. And then the last factor, x minus 1, is just one of them. So I just put x minus 1 with a c. And of course, we put constants, as we always do with linear factors, in the numerator. All right, I'm going to go through the rest of this very quickly because it's the same process that I described in the last video. So hopefully by now, you've kind of got that part down a little bit, hopefully. Otherwise, this is some more practice for you. So we multiply both sides by the least common denominator. Okay, we multiply the right-hand side by the least common denominator, which is always this denominator, always. We multiply the right-hand side by the least common denominator. On the left-hand side, the denominators just cancel out, and you get the numerator. And on the right-hand side, you can see that when you multiply through each one of the 3 terms by the least common denominator, you should end up with this. Multiplying all of the terms together, you're going to end up with this. Now I'm going to do the equating of coefficients. So here I take the x squared terms. So I don't have an x squared term on the left-hand side, so I have 0 x squareds. But I have a 2ax squared and a 4cx squared. Secondly, I take the linear factors. I have x, and I have minus 3ax plus bx minus 4c, and I'll do that in orange. So that comes from here, here, here. And then finally, I have the linear factors, a minus b, and the c is equal to the linear factor on the left-hand side. Then, going over here, we just get rid of the variables. And so I have 3 equations and 3 variables. So if you take the second 2 equations, eliminate the b, you're going to get an equation in A and C. And I think I did some of the work for that down here. So if you want to see how I eliminated to get this A, B, and C, all of the algebra is down here. Okay, all of this down here is how I got the A, B, and the C. So I'm just going to get into the calculus part here now. So we've got A, B, and C. And so I put A in the numerator, B in the numerator, C in the numerator. And now we want to integrate. And so the first one is just a log rule again. Okay, 2 times the natural log of the absolute value of 2x minus 2. And the same thing with the last one. It's a log rule. The one in the middle, you're going to have to use some u substitution. Okay, because you have the 2x minus 1 squared. So I did that down here. Let u be equal to 2x minus 1. du is equal to 2 dx, or dx is equal to du over 2. And then by just rewriting this so that it looks like this, you can bring that 2x minus 1 squared up to the numerator, make it 2x minus 1 to the negative 2. And substituting in the u's, you end up with this. So you just end up with the power rule problem. And so we end up with this once you integrate it. And so that is what I put up here. So all this work down here is to get this part right there. Okay. So I hope this stuff makes sense to you. Again, this is just some college algebra. Again, solving systems of linear equations by elimination method. It might be a helpful video to watch if you're a little bit stumped on what goes on there. Just let me know. I can always kind of throw together another quick video perhaps on how to do some of that. And one more for this video. This is going to be a fun one. Oh, wait a minute. This is an irreducible quadratic factor. Yeah, this is an irreducible quadratic factor. I think I got a couple mixed up here. All right, so that's it for that. That's it for this video. All right, I'm going to do irreducible quadratic factors in the next video. Bye-bye.